In this video, I will be discussing percentiles for group data. Now, before we discuss about how to solve the percentiles for group data, let us define first what are percentiles. Percentiles are values that divide a set of data into 100 equal groups. There are 99 percentiles, which are denoted by P1, P2, up to P99. In such organization of data, 1% falls below P1, 2% falls below P2, and so on until it reaches 99%, which falls below P99. Now, the formula for getting the percentiles for group data is Pk is equals Lb plus Kn over 100 minus CFB all over Fpk multiply all by I. Now, let us understand what are these abbreviations in the formula. The LB refers to the lower boundary of the PK class. N is equal to the total frequency, and the CFB is the cumulative frequency before the PK class, and the FPK is the frequency of the PK class, and the I is the size of the class interval, and the K is the nth percentile where n is equals to 1 to 99. Now, to better understand this formula, let us have an example. Sam collects plastic bottles every month from the 50 houses in his barangay. The data for the collection last month is summarized in the table below. Calculate the 15th percentile, 50th percentile, and the 93rd percentile. Now, before we compute the 15, the 50th, and the 93rd percentiles, let us make a table containing data that will be needed to solve the percentile. In our formula, back in our formula, we need LB and the cumulative frequency in the formula to solve the PK value. So let us rewrite the table containing those values that we needed. So I will rewrite the weights of the plastic bottles collected per house in kilogram into class interval. And the number of houses, the frequency, I will just denote it as letter F. And we need LB and the cumulative frequency. Now I will just copy the class interval based on the given 18, 20, 15 to 17, 12 to 14, 9 to 11, 6 to 8, and 3 to 5. And I will just copy the frequency. 7, 8, 12, 10, 9, and 4. Now, before I proceed to finding the LB per class interval and the cumulative frequency per class interval, let us identify first the size of the class interval. The size of the class interval is denoted as I. So from 18 to 20, what is the size of this interval? This is 3 because in 18 to 20, there are 3 numbers, 18, 19, and 20. That is the same as 15 to 17, which is 15, 16, and 17. Now, we need to get the total frequency. And to get the total frequency, we will just have to sum all of the values in the column. So the total sum of the frequency is denoted as n. So 7 plus 8 plus 12 plus 10 plus 9 plus 4 is equals to 50. Now we will find the LB or the lower boundary per interval. Now in getting the lower boundary per interval, we will just have to look at the lowest boundary per interval. So 18 to 20, you have 18 as the lowest boundary. So we will just have to subtract 0.5 or zero point 0.5 to the lowest boundary, which is 18. So 18 minus 0.5 is 17.5. 15 minus 0.5 is 14.5. 12 minus 0.5 is 11.5. 9 minus 11 is 8.5. And 6 minus 0.5 is 5.5. And 3 minus 0.5 is 2.5. Now, let's find the cumulative frequency per class interval. In finding the cumulative frequency per interval, we need to make use of the total frequency as the first data of our column here in the cumulative frequency column. So 50. And then we will have to subtract the cumulative frequency of the class interval 18 to 20 to its frequency, which is 7. And we will do it per row. So 50 minus 7 is equals to 43. 43. And then 43 minus 8 is equals to 35. And then 35 minus 12, that is 20, 23. And then 23 minus 10, that is 13. And 13 minus 9 is 4. Now, how will you know if your cumulative frequency is correct? Now, you look at your last column of your table. If the frequency of your last class interval, which is in this case 3 to 5, if its frequency is equal to the cumulative frequency, which is the case here, 4 and 4 means that your column for cumulative frequency is correct. Now let us find the 15 percentiles in the problem. Now remember that the formula for the percentiles for group data is pk is equals to lb plus kn over 100 minus the cumulative frequency before the pk class all over the frequency of the pk multiplied by the class interval. Now, we look at the formula and we notice here the kn over 100. The kn over 100 here refers to the position of the pk that we are finding, which is p15 in this case. So let us find the position of the p15 first. So the position of p15. So the formula is p15 equals kn over 100. Now let us plug in the value. The k here is the 15, which is p15 or pk. So 15 times the total frequency, which is 50 over 100. So our p15 is, let us compute, plug into the calculator, 7.5. Now what is the relevance of this 7.5 in our problem? Now, we use the position of the p15 to find which class interval we should find, or we should use the values of our LB and the cumulative frequency and the frequency. So 7.5, we look at our cumulative frequency table here. Now, in our cumulative frequency table, where does 7.5 falls? So to better understand this, let us go per row. So let us start here at the 18 to 20 interval. So we have 50 here, and below we have 43. So that means in this class interval, the cumulative frequency interval is 44 to 50, because the last boundary of the cumulative frequency in the 15 to 17 class interval is 43. So in the 18 to 20 class interval, we will start at 44. The same as in this case, 43. So we have sa below the 15 to 17 interval, we have 35. So here in this interval, it will start with 36 and end with 43. So the same as this way. The last is 23 here. So we have 24 to 35. And the last one here is 13. So 13 to 23. And the last one here is 4. So we will have here 5 to 13. And the last one here is 0 to 4. Now, where does 7.5 fall? 7.5 is between 5 and 13. So that means we will use the values in the 6 to 8 interval. So let us list our values. So we have LB here, LB. Our LB is 5.5. And we also need the frequency of the P15. The frequency for P15 is 9. Now, we will not use the cumulative frequency of the 6 to 8 interval. Rather, we will use the cumulative frequency below it because we are referring CFB, which refers to the cumulative frequency before the PK class or before the P15 class interval. So our P15, it has cumulative frequency of 13. Now we will use the cumulative frequency below it, which is equals to 4. So I will highlight it 4. 4. Now we will be able to compute for the P15 or the 15 percentile. So I forgot to put here the I, the size of the class interval, which is equals to 3. Now let us plug in all the values. So P15, we have LB plus Kn over 100 minus the cumulative frequency before the P15 all over the frequency of the P15 times I. So LB is equals to 5.5 plus our Kn over 100 here is our 7.5, the position of the P15, minus 4 all over frequency, which is 9, times I, which is equals to 3. So our P15 here is equals to, let us plug into the calculator all the values, 5.5 plus 7.5 minus 4 all over 9 times 3. So we have 6.67. Now let us interpret our answer. Now how do we interpret this answer? We have P15 equals to 6.67. So this answer means that 15% of the houses gave less than or equal to 6.67 kilograms of plastic bottles to some. At the same time, since 15% gave less or equal to 6.67 kilograms, that also means that 85% gave more than or equal to 6.67 kilograms of plastic bottles. Next, we are tasked to find P50. So the same process, I will rewrite the formula of the PK again. PK is equals to LB plus Kn over 100 which is the position of our pk, over the cumulative frequency before the pk, all over the frequency of the pk, times the size of the class interval. Now we will find first the position of our pk, or the p50, which is equals to kn over 100. K is equals to 50 times n is also equals to 50 over 100. Now p50 here is equals to, plug into your calculator, 25. Now we will use the value of 25 to find in which cumulative frequency interval does it fall. So 25 here, if we look at our cumulative frequency table, 25 falls between 24 to 35. That means that the class interval that we should use the values of this class interval to our formula is 12 to 14 interval. Now we will use the values of this row in order to get our P50, or the 50th percentile. So let us extract the values. So LB, so the LV of this interval is 11.5, whereas the frequency of this interval is equals to 12. And again, the cumulative frequency that we should use is the cumulative frequency before the P50. So here we will use, instead of 35, we will use the 23. 23. And the class size interval, which is equals to 3. Now let us just plug in all of the values to our formula. LB is 11.5 plus Kn over 100 is equals to 25 based in our solving previously, minus the cumulative frequency before P50 is 23, all over frequency of the P50 is 12 times the class interval size. Now let us just plug in all the values to the calculator. 11.5 plus 25 minus 23, or all over 12 times 3. So you have 12. So the answer is 12. P50 is equals to 12. So how will we interpret this answer? So we can say, therefore, 50% of the houses gave less than or equal to 12 kilograms of plastic bottles. At the same time, we can also say, since 50% gave less than or equal to 12 kilograms, we can also say that the remaining 50% of the population, the remaining 50% gave more than or equal to 12 kilograms of plastic bottle. So that is how you interpret your answer. Now, the last one, the last part of our problem is P93, or the 93rd percentile. So I will copy again. Here, I will rewrite the formula LB over, or rather, times Kn over 100 minus CFB. Let me write. PK is equals to LB plus Kn over 100 minus CFB, all over the frequency of the PK times the class size interval. Now let us find first the position of P93. P93 is equals to Kn over 100. K here, in this case, 93 times the total frequency, which is equals to 50, all over 100. So P93 is equals to, let us plug into the calculator, 93 times 50 all over 100, that is equals to 46.5. Now we will use this answer to find our position and in which interval should we extract our values of the LB, the frequency, and the cumulative frequency before the P93. So 46.5 falls between the 44 to 50 interval. So we will use the values in this interval 18 to 20, in this class interval 18 to 20. So let us extract the needed data or value. So we need LB, which is equals to 17.5, and we also need the frequency of the P93, which is equals to 7, and we will be needing the cumulative frequency before the P93, which is equals to 43 here. And of course, our class size interval, which is equals to 3. Now let us just plug in the values into the formula. LB is equals to 17.5 plus Kn over 100, that is the position of P93, which is equals to 46.5, minus the cumulative frequency before the P93, which is equals to 43, all over the frequency, which is 7. And multiply this all by the class interval size rather. So P93, plug in the values into the calculator. So we have 17.5 plus 46.5 minus 43 over 7 times 3. So you have 19. Now, how will we interpret this answer? So we can say, therefore, the for information, the triple dots refers to the word therefore. Therefore, 93% of the houses gave less than or equal to 19 kilograms of plastic bottles. At the same time, we can also say the remaining 7% gave more than or equal to 19 kilograms of plastic bottle.